Hello. For these two, the proportion test or hypothesis in Chapter 9, it's this one. So the mean hypothesis test is this one, proportion is this one, and that will give you the Excel file. Okay, so here's the Excel file. And let me bring the question up here. This one. This one first. Test the claim that a proportion of people who own cats is larger than 70% at a 0.005 significance level. So we want greater than 70%. Well, 70% written as a decimal is 0.7. And we want greater than. This one's not equal to, this one's less than, this one's less than, not equal to. These two are greater than. But we wanted to test the claim that the proportion of people, so it's the P. And that's why it's this one and not this one. So it is greater than. Because it's greater than, it arrow's pointing right. That's a right tail. Now to find the test statistic and the p-value, you can use this table and you plug in this blue area. Our level of significance was, I thought it was 0.005. Let's go back up and check. Yeah, 0.005. Sample size was down here 800 people. The number of yeses 73%. So we want 73%. .73 times 800 is 584. And the population proportion oh, that's your P, 0.7. And then your test statistic, 1.85. Your p-value, it all depends on what tail it is. This was a right tail, so it's the 0.032. Since the p is less than alpha, or p greater than alpha, well, alpha is 0.005, so p is greater than it. You fail to reject, so you do not reject. The other problem, you're conducting a study to see if the proportion of men over the age of 50 who regularly have their prostate examined significantly less than 0.37. So we're testing less than. For this one, then, you should have greater than, or you could have equal to the 0.37. Because we were testing less than 0.37. This one would be less than. So your alternative is always which one you're testing. To find the test statistic and the critical value, we use this again. We wanted, using a 5% level of significance, 5% would be 0.00, wait, 5%, 1, 2. Got to get rid of a 0. It would just be 0.05. Our sample size is 800 men. 200 have their prostate regularly examined, so our yeses would be 200. And then we're testing 0.37. because that's our null and alternative hypothesis. So your population proportion always comes from your alternative and null hypothesis. So here's our test statistic, negative 7.03. The critical value is over here. This is a left tail because it's less than. So it's this one, negative 1.645. Now if we go down here, left tail, and then you want to put your value here and go left because it was a left tail. It actually should be I guess you leave it there. It chooses it for you. And so we want it here. And so then we reject the null hypothesis by comparing your critical value whoops, went too far. Oh, well, that's not explaining it. The p-value is left tail. So this would be 0. If you look at the left tail for your p-value, because this is 10 to the negative 12, this would go, the decimal would go to the left 12, so it's 0. And 0 is less than 0.05. So we reject the null hypothesis.